Now that we've taken the time to introduce you to AutoCAD's interface, you need to know how to work within AutoCAD. Now, one of the most basic and essential operations in AutoCAD is actually starting a file. You can't do anything without the right drawing, of course. So there are two methods to take here. One is to start a file that is brand new. The other is to open up an existing file. So let's start with the easier of the two. Open an existing file. AutoCAD, just as you're going to find out, has several ways to start a command, the ribbon or the command line. Opening a file is no different. AutoCAD can do whatever it does, and it can do it seems like a million different ways to do the exact same thing. So you'll get used to that. You can go up to the application menu, left click on it, and go to the open button. Or you can go to the quick access toolbar and click on the open button. Or you can just type open on the command line and press enter. So you have a lot of options to do the exact same thing in several different ways. So I'm going to browse to my project files, and I'm going to open up a file. I'm going to open up the beam clamp drawing file. And this is just a regular file. It's actually a 3D model that I've created for a project for a client a few years ago. It's just a simple beam with a clamp apparatus that it made. And this is actually designed for a dry slip boat house where they store boats in a dry area throughout the wintertime when they're not using them in the water. They use these clamps to set the boats on these beams. This is kind of what it looks like. So that's how you open a file. So you can just type in the word open. You can go to the application menu and go to open. Or you can go to the quick access toolbar and go to open. Now you can also click on the file tab here, click on the plus button. This will open up the new tab. And you can come down here on the left where it says open files. Click on the open file and it brings you to the exact same interface. So there are a lot of ways you can see here to open up an existing file. Now if you need to make a new file or start a brand new file, new project or anything like that, don't worry. That's really just as easy. Only this time you have a few choices to make. When you turn AutoCAD on, a lot of times it'll either start in a blank template file like this, or it'll start on your new tab button. Either one of those are fine, and you can get to everything you need from either direction. So if it starts like this, the drawing, you can just save the file and you're good to go. But a lot of times I recommend that you don't do that. I recommend you start with a template file or anything like that. So if you have a template file, that's great. Go to your new tab and go to the templates button right here for start drawing. If I click on the start drawing button, it'll just open up like this into our default template. But if you click on the buttons bar underneath it, it'll give you a list of different template files that you may have. Click on the AutoCAD.dwt for right now. There's an example, and there's a new file. Just save it and you can get to work. So if you have a template file that you want to use, and AutoCAD does come with several of their own, then you can choose one of those instead of the ones that come with AutoCAD. That's perfectly fine. So you can also get to that from the quick access toolbar up here. You can click on the new button icon. It's right here on the left. Again, you can also go to the application menu, go to new, and just click on the drawing option. You can use the new tab as we discussed earlier, or you can type in the word new. So that's about 4 or 5 different ways to start a brand new file. And again, you get your options of different template files. Pick the one you want, click open. Now, template files have a different format than regular AutoCAD files. You can tell them apart by their file extension. Now, regular AutoCAD files end in a .dwg file type. Template files are similar, but they're a little bit different. They end in .dwt for drawing template files. In all honesty, you could use a regular DWG file as a template if you wanted to. Just open it up as you would in any existing file and then start working. Now, the danger with doing that, though, is when you save the file. Because when you open up the file, any changes that you make to it and you save them will override that old file. So be careful with that. If you save any of those files, a template file, AutoCAD will ask you what and where you want to save the file to. So I did that process here with the new for drawing 5, it says here. So if I type in the word save, AutoCAD asks me, hey, what do you want to call this file and where do you want it to go? However, if I open up an existing file like this beam clamp and I click save, it's going to tell me, hey, you're going to save it here and you could overwrite it. But this will give you a chance to change the file name, save it something different. That's good. But if I click up here on the quick access toolbar, it saves right over the top of my file. I've just replaced my old file. So you have to be careful with that. So keep that in mind. Now, using template files to start your drawing with is one of the best CAD practices that you can ever have. That's because you can set up a template file with any settings, blocks, layers, and other items in it ahead of time. Otherwise, you're going to have to customize your drawings every time you make a new one. Now, this process, though, using the template file, ensures that all of your drawings will work properly and that you'll only have to set them up one time. Now, if you need different types of drawings, then just make different types of templates. That's okay. A template can have anything in it that you want, special notes, a title block, or any standard company sticker or logo or anything like that. Templates make you work faster by doing your work for you ahead of time. And remember, and I'm going to say it over and over again throughout this video, that the less you have to do, the quicker you can get done. And that's why we use CAD. I'm trying to not jump the gun here, but you are going to need to know how to end your AutoCAD session. I know you haven't even started yet, and I'm already telling you how to finish. That's okay. Just like there are several ways to open a file in AutoCAD, there are different ways to save and close a file. In fact, though, they're very similar in the way you open a file. Now, there are two main ways to stop using AutoCAD: close and exit. Two different commands, and they mean different things. Now, you can type either one of them on the command line. So if you type in the word close, that will close the current file. Now, if you have several files open and you type in the word close, then only the current file will go away. If I type in the word exit, every file that you have open will close, will go away, and AutoCAD will also shut down. Now, with either command, as you can see here, this little prompt that says save changes to drawing 1, that's the file that I have here, it will give you this option. So if you type in exit or type in close, if you've made any changes to it since your last save, then the closing or exit command is executed. AutoCAD will ask you and will give you a prompt that says, hey, do you want to save your work? And you probably do, but in some cases you might not want to. So you can just click no, and it will go on and closing everything out or exiting whatever it is that you've asked AutoCAD to do. So those are two different ways that you can close it. Now you can also click on this X right here. If I click on this X, this will execute the close command. So it'll close just that one file that I have open. If you have no files open at all, then it will bring you to the new tab right here. One way to shut down AutoCAD altogether is to go up to the top right and click on this big red X, and that will close all of your open files, asking you to save them first, and then it will shut down AutoCAD altogether. So while you're working and long before you are through for the day, you need to make sure you save your work. So I'm going to open up a file here, just a basic one. Now, the three most important tips that I can give to you today are to save your work, and the third tip, yes, save your work. You must save early and save often. Get into the habit of saving every 5 to 10 minutes or so. It's that important. Now, AutoCAD does have an autosave feature, but I've found it to be very unreliable. So just be careful with that. Now, there are several ways to save a file, just as there were to open them. So you can click up here in the quick access toolbar. You can click the save button. If you click save, it'll give you a prompt saying, hey, what do you want to call this file and where do you want to save it to? Figure that out. Browse to your location that you want to go to. Type in the name that you want to give it and click the save button. Now you can type in the word save and it will do the same thing. You can come up to the application menu. You can click on the save button and it'll go here. If you haven't given your file a name or haven't saved it first, it'll prompt you for that. Now the save as command will do the exact same thing. So if I've saved this file, I'm just going to call it drawing 6. And I make a change, say I draw a line, and I click the save button here, it'll automatically save it and save it to where I had it before. So you have to be careful. That will override any of your files. Now, if I click here at the save as, regardless of what I've done to it, it will always prompt me for a file name and location. I can get to those same things through the application menu, save and save as. Now, the save is really executing a command called QSave or quick save. So it does that very quickly, it saves it, and this just makes sure that you've saved or retained the progress that you've made in your drawing file. Now, another way to do that is even quicker, and that's by pressing the Control key and the letter S at the same time. If I press the F2 button, you can get to the command line up here and it says QSave. Press the F2 button again to collapse that. So that's a habit. When working with objects in AutoCAD, you need to select items that are already there. This is going to happen all the time. And there are many different ways to make sure you're picking the exact objects that you want to select. So before we get started though, let's open up a file that has some objects in it that we can actually select. Let's go to the folder for this project chapter and open up the Mechanical Example Imperial Drawing file. Now this is just a simple 2D drawing. It has 3 different views of a flywheel. You can see what it looks like from the top, from the front, and then from the side. In fact, the top and the side are almost identical. Now, there are many different ways to select objects inside AutoCAD. Now, when you're using an editing command, let's say like the move, press return, and you are prompted here to select objects. Now, it's asking you to select the objects that you want to move. Now, they aren't listed here, but there are several different options for you to choose from when selecting an object or objects. Now, one method that's very straightforward is just to pick the objects. So if I want to move this entire view here, all I have to do is just zoom in and left click on the objects that I want to select. When you move your mouse over an object, it will be highlighted like this. And then when I left click on it, that object will be selected. So if I execute the move command right now, I'm only going to move this line and this line. So I can just keep picking all of my objects. And as you can see, I'm eventually going to get there. Now this can be very tedious. Now the pick method is very tedious when you need to select a lot of different objects, especially if there are a lot of small objects. A better way of selecting multiple objects is to use a selection window. But however, the pick option is perfect when you only want to move one thing. So the other 2 methods that we can use are a window selection or a crossing selection. And now there's a new selection mode in here also called a polygon select option. So let's look at the crossing windows first. I'm going to escape out of this command so we can start it brand new. And this time I'm going to use the copy command. So start the word copy, type it in, C-O-P-Y, and then press enter. Now we've started the copy command. And you can see the dynamic input prompt by my cursor here says select objects, as well as on the command line. It says select objects. Now to do a crossing window, it's very simple. Left click somewhere in your drawing area that's not an object. So just in this open space area, left click, move your mouse to the left and down. Now you can see here, everything is getting highlighted as I use this crossing window selection. That's what it's called. So when you select a point, move to the left and or down. This creates a crossing selection window. Everything this window passes through will be selected. You can see the very top part right up there. I'm going to zoom in a little bit. These items there at the top that are still red are not being selected, so they're not highlighted. So if I want to pass through something, I don't have to have this entire line selected inside my window, just part of it. Anything my window here crosses through will be selected. Left click again, and all of those items are picked. See, that's quite simple, very easy. Much easier than clicking on each one of these one at a time. I'm going to escape out of there. I'm going to start the copy command again. Type in copy, press enter. Now I want to show you a selection window. Selection window works exactly the same way as a crossing selection window, only in the opposite direction. So if I left click and I move to the right, and I can move up or down. The main key here is to get to the selection window is to move left, and a crossing window is to move right. Now, the difference between the selection and crossing is the selection, everything it passes through is picked. Now, on a selection window, it only selects things that are completely inside that window. So you can see here, I'm picking this entire view except for that middle center line because part of it is not inside my window. It's not selected. If I press return, pick a base point, just left click anywhere, move to the right, left click again, press return, and I've copied that view. So it's very simple, very easy to do. And I can always start my selection before I start my command, or I can do it after. Now there's another selection option that you have here. Let's say I wanted to copy just these circles out, this center line and all the other center lines, and then the main shaft here for my flywheel. That's fine. I'm going to type in the word copy to start my copy command, press enter. And when I do my crossing windows, you select an open space somewhere and let go of the button and you drag left or you drag right. You can press your left mouse click button again. That'll end that selection. But this time what I'm going to do is I'm going to left click and hold. I'm not going to let go of it. I'm still holding it down and I'm moving my mouse. Everywhere I move my mouse creates a selection window, but it's like a polygon here. It's a weird amoeba shape, and it's only going to get the items that I select inside there. Then I let go, and just those items are selected. Press return, pick a point, zoom out, and there, press return, right click, and press enter to cancel out of there. So you can see here, I have these different options. I have the rectangular crossing window and selection window, and then I have the polygon shape that I can use just by left clicking and holding. So these are very useful tools, and they're very helpful, and they're very quick to use. Now, sometimes you want to select objects before you start the command, and that's perfectly fine. There's really nothing wrong with that. As I showed you before with these, I started the copy command, and then I picked all my objects. Well, I can pick all my objects right now, and now type in the copy command. Press return, and everything is already selected. It's gone through the selection process for me already. I just need to select by left clicking my displacement point, and I can keep copying these all that I want to. So whichever method you want to use is perfectly fine. I've found that I've just gotten into the habit of selecting things first, and then I've picked everything. Now, one advantage that you do have by starting the command first, copy, and let's say I just pick all of these objects. Now, before I press enter to finish the copy command, let's say, oh, wait a minute, I didn't mean to pick these objects. That's okay. Press down the shift key and then select everything again. This is a deselection or an unselect option. I can come in and I can just pick the individual objects if I want to get rid of them, or I can use a crossing selection. I can use my polygon shape again. Holding down the shift key while you select objects will remove them from your selection set. Let go of the shift key, press return, and you can go on. There are many ways to work within AutoCAD. There are the ribbon and the command line, to name a few. The ribbon is rather straightforward. You click on the ribbon tab that you want, find the panel, and click on the command, and it draws whatever it is you want it to do. Now, the command line, though, can be a bit more involved. In fact, no matter what, if you use the ribbon, toolbars, menus, or whatever, you still have to use the keyboard for input. There's no way around it. Now, there are some tricks that you can use, though, to be more efficient with it. In other sections here, we've talked about entering commands on the command line, like line, arc, circle, whatever they are. And we also discussed command aliases for those commands, like L for line and A for arc. But what if you type in the wrong thing? It's okay, we all do it, it happens. Now, you can work in the command line as if it were a single line of text in a word processor. So if I start typing in line, oh wait, no, that's not what I want, I can backspace. Now, the command line and dynamic input work almost essentially the same way. You can turn off your dynamic input if you don't like it, if that gets in your way, by going to your status bar. If you don't see it down here, click on this customization button. It's on the far right. You'll find it up here at the top, dynamic input. Now, when I toggle this off or on, it puts it in the status bar. Remember, if it's blue, it means it's on. If it's gray, it's turned off. So now that I've turned off the dynamic input, if I type in the word line, it only shows up in the command line. Right here, it pops up that way. Whichever way you want to work, feel free to work that way. But if you're in the command line, remember, you can use it just like you can a regular word processor. You can use the home buttons, the end keys. You can use your arrow keys to navigate through it left and right. You can use the backspace key to erase them. You can also use the delete key to erase things to the right. Also remember that by pressing up and down with your arrow keys, that takes you through the list of your recently used commands. And when you execute a command, like the line command, there are usually some sort of instructions or requests given to you by AutoCAD. It needs more information from you. For a line command, the first prompt that it gives you is it asks you to specify your first point. And when you do that, you can see there's an undo option. I can click on here inside the command line to execute that option. Now, a great example of many options is the circle command. When you first start typing in letters, you can see here in the expanded list here, it gives you options for your different commands. Left click on it inside the command line, and you'll be able to select and start running that command. Now, the circle command, as I said earlier, is a good example of giving you different options and choices inside the command line. Now, by default, you'll start a circle at its center and then give AutoCAD the radius. Now, what if you want to enter in a diameter of the circle instead? Start the circle command, pick your first point, and then you'll see here I have options. I can enter in the radius, there's a default value right there, or I can click on the diameter option. And now I'm entering in the diameter of my circle. Let's look at it again. Start the circle command again, and you'll see here that I have other options. 3P for 3 points, 2P for 2 points, or TTR for tan radius. We'll get into the nitty-gritty aspects and details of the circle command in another video. But I can just pick any of these options in the command line for those options, or I can type them in. Now, which ones do you type in? They'll be the ones that are blue and all caps. So I can type in 3P, 2P, or just T. So if I type in 3P, press enter, I'm now drawing a circle based on 3 points. I pick my first point, my second point, and then my third point. And each time I'm doing that, the command line gives me a prompt. So my point here is keep an eye out for these command options and instructions. If you're not sure what to do next to create a specific type of object, the command line is telling you what you need to do. So keep that in mind. Keep your eye on the command line. To enter in any command, you just type. So I can type in REC for rectangle, and then I press enter, and I draw a rectangle. Now I can also start typing in REC and then press the space bar. Now the space bar is the same thing as the enter key on the command line. It's a nice option because the space bar is very large and it's a lot easier to hit than just the enter key. Hitting the enter key or the space bar after a command will also restart the last command you just did. So the last command I just did was rectangle. I hit the space bar and it starts it again. Or if I hit enter and I get to it again. So that's a nice little thing to keep in mind. It's very handy. Now, selecting objects can be difficult. Now, sometimes there are just too many to get it right, and you only need just the circles, but they're hard to get to. Now, in this case, they really aren't, but I'm just going to use it as an example. So let's use a filter. Let's start by opening up the Properties palette. Press Control and 1, and that will open it up. Now, it may dock for you right away, or it may be opened up and be pulled off, look something more like this. That's fine. It'll all work the same way. If you grab the bar here on the tool palette by left clicking and holding, you can move it around and then just dock it into place by dragging it to the side. That's what I'm going to do. So there's a filter option in the Properties palette. First, we're going to select all of our objects. Then we're going to come up to this little spot here on the top right called Quick Select. Select it, and this gives us a filter. Now I can say entire drawing, or it's in our object selection, which is what we have now. And I'm going to say circle. Now these are the only things I want, are the circle. Make sure to tell it to include my new selection set. I'm going to click OK. So now I only have my circles selected. Now I can delete them, move them, change their colors, whatever it is I want to do. Now another little thing I want to give you a tip on is about canceling a command. You press the escape key. It's very easy to do, but be careful of the dreaded F1 button. It happens to all of us CAD users all the time. Hitting the F1 button will open up the help menu. So if I press the F1 button, it opens up the AutoCAD help menu. Now, it's happened to me, I don't know, millions of times. I've missed the escape key and hit the F1 key instead. That happens. Hitting it is a pain. A lot of people have just even pulled out the F1 button so they don't hit it by accident. So keep that in mind. But if you also need to get help, pressing the F1 key is a very quick and easy way to get to it. Now, when you're in a command, you may need to repeat recent input. When that's the case, you can just right-click for your shortcut menu, and the option to insert recent input is there just a click away. So let's start our rectangle command. I'm going to type in REC, press enter. I'm going to pick a point here. If I right-click and hold, it will get me to recent input. It's an option. And a lot of these are just coordinates. So I can click one again, and it popped me right to that same coordinate. Now that's really cool if you're trying to draw objects to the exact same spot, or you need a similar circle or length or diameter or something like that. So it's there. A lot of times you don't have to retype that same radius again or that same coordinate point. It's all right there. So it makes it very easy. So this is just a few tips and things to keep in mind when you're working with AutoCAD. When you make a drawing in AutoCAD, it is designed in some sort of linear measurement. Most of the world uses the metric system, while other places use the imperial system of feet and inches. Now, I'm in the United States, so I typically use feet and inches, so I'm most familiar with those, which you've probably realized by now. Now, AutoCAD doesn't really know what those units are. It only sees generic units. Drawing units in AutoCAD are relative. It only interprets the units when you go to print your drawings, or compare it with other files that you've inserted or referenced. Now, it will translate your drawings units to fit the way you tell it to on your paper. Now, AutoCAD will take your line work and apply it to a scale factor when it prints. It will take the size of the paper you're printing on and scale your drawing objects accordingly. When you draw, make sure to know what units you are using. Your units can be anything. It can be feet, inches, meters, kilometers, or even parsecs if you're going to make some kind of space travel map, for an example. But it doesn't matter. What does matter is that you draw to full or real scale and in one unit. AutoCAD can really only draw in one set of units at a time. Now, there is a units setting where you can define or at least declare what your drawing's units will be. Now, to get to it, type in the word units. Press enter. Now, you can also get to this through the application menu. If you click on it and go down to drawing utilities and select, and here is the units control button. It pops up the same interface system here. Here you will designate the type of units blocks will be inserted in or other drawings. It also sets up the way your units will be displayed. You can choose from architectural, decimal, engineering, fractional, or scientific. Now, when you draw with the architectural, engineering, or fractional settings, AutoCAD is assuming that you're working in inches and will display your units in feet and inches. So it will say, hey, this is 5 feet, 7 inches long. But keep in mind that all of your units are in measurements of inches. So if you type in the number 1, it's drawing it at 1 inch. If you're drawing in the number 12, 12 will be 12 inches long. Yes, it will also be equal to 1 foot, but AutoCAD will interpret it as 12 units long. Now, it's smart enough to know that 12 inches is a foot and will display your object as being 1 foot, 0 inches long. And when you're entering in objects to specific lengths for architecture, you can tell it to be 2 feet, 0 inches, or you can type in 24 inches. So keep that in mind. Architectural format will display fraction of an inch in fraction form, while the engineering setting displays them in decimals of an inch. Now, the other unit settings that we have here can be used to represent any form of measurement. The decimal setting will display your objects in units and decimals. A scientific displays them in scientific notation, and fractional will display them as fractions of units, typically inches. So the decimal setting is probably the most common setting for units used in AutoCAD, followed then by architectural setting. It may be the case that you will never use all or more than one of these display settings throughout your career, and that's perfectly fine. So once you have defined your type of length, meaning how is it going to be displayed, architectural, decimal, etc., you have to select your insertion scale. Now, the insertion scale will tell AutoCAD exactly what each unit actually represents. You can see this is a long list: inches, feet, miles, millimeters, centimeters, meters, kilometers, micro inches, mils, yards, all the way down, as you can see here, to light years and parsecs and even astronomical units. Just a bit of trivia: 1 astronomical unit is equal to the distance from the Earth to the Sun. So if you're making drawings on that type of a scale, by all means use that. Typically, you're going to use probably inches, feet, millimeters, centimeters, and perhaps kilometers. Now, not only do you have to work in measurements of length, but you're going to need to work in angle measurements as well. AutoCAD 2 has a lot of choices for that as well. You can display your angles in degree decimals, and that's all controlled here. Degrees, minutes, seconds. Surveyors will often do this. You can display it in gradians, radians, or even survey units. So survey units or degrees, minutes, seconds can be done for surveyors, but you might see them in either format. So if something doesn't look exactly right, take a look at it. Now, your precision that you have here for both of these angles and lengths, this shows the precision of how these values will actually be shown to you. So you can go with low precision and not display any fractions of your inch at all, or you can go all the way down to 1/256th. And maybe this will give you a better idea. In your decimal format, you can go down to no decimal, or you can go down to about 8 or so places past the decimal. Now, the amount of precision is up to you, and it fits your needs. Same thing with the angles. These are degrees, minutes, seconds that you can go into for that. Or if you are in just decimal degrees, this is how many, like 45.45 degrees. So this is just going to depend on what you need. A lot of times 2 decimal places will be more than enough. Now, for both of these settings, though, you need to set the precision on your measurements. It's important, though, because it will display in your dimensions when you dimension an object. It'll say it is 12 feet, 0.0000 inches, or whatever that case may be. One of the problems that you have to deal with AutoCAD is that it is way too precise for a lot of our applications. Now, you can draw much more precisely in AutoCAD than you could ever build for a lot of different things. So keep that in mind, and just because you can draw something in AutoCAD, that doesn't mean that it can be built that way. Working within a certain set of defined units is crucial in AutoCAD. You can only work with one set of units at a time. So how do you do that? Well, first you have to define your units. This is where a template file can come in very handy. It can already be set up for you and you just work with it. But if it isn't, then setting up the units in a file is actually quite simple. Type in the word units to get to your drawing units manager. Let's set our units. For this example, let's use decimal, and we're going to use feet. So here we define the length, the type, which we've talked about in a previous video. And here we defined exactly what the units are going to represent. In this case, 1 unit equals 1 foot long. Now, it's good CAD practice to draw everything to length, to its true length. That means that if you need to draw a room that is 15 foot wide by 20 foot long, then draw it exactly at 15 feet wide by 20 feet long. Don't scale it up or down, even if you need to draw in a different scale for your view on your drawing. There's another tool in AutoCAD called viewports that will handle the scaling for it. Now, this is good for several reasons. 1, you are always creating an accurate drawing by drawing it to scale. And 2, your drawings will be properly drawn to scale when printing. And 3, others that need to use your file will know exactly what's going on with your line work. They can trust it. They know that, hey, this is drawn at 3 meters wide. It's 3 meters wide. So typically AutoCAD users will work with one set of drawing units, whatever they are. Now, sometimes though, you will need to work with files that are drawn in different units. And that's why it's important to define your units in the unit manager. If this is done properly, AutoCAD can interpret the different units accordingly and scale the line work as needed when you bring it into your drawing. Keep in mind that not all CAD users are responsible as you, and they may not have properly set up their units. It happens from time to time. Now, it's a good idea, though, to check the file before you work with it. I'll give you an example. Let's open up the architectural example file here called Imperial. Now, this is a very simple drawing. It's just a hallway here with some windows and a few doors for a couple of rooms. Now, this is set to architectural units. So if I open up the unit manager, we'll see here it's set up to architectural units a precision of 1/32 of an inch, and each unit is set up as 1 inch. Now, if we open up in that same folder, the Civil Example Imperial, click Open. This is just a simple roadway here, a little pond, and a couple of residential lots with an area where a building is going to be at. Now, if we type in the word units, we see that this drawing is set up to be decimals of a feet. Precision is at 4 decimal places, and our units are set up to feet. So whenever we type in the number 1, we're drawing at 1 foot long. In our other drawing here, the architectural example drawing, when we type something 1 unit long, it's 1 inch long. So now if I want to reference this file in, type in xref, this will open up my xref manager. Now this will allow me to reference one file into another, and that's what I'm going to do here. I'm going to reference in my architectural example file, and here it is. I'm just going to insert it right there. So now you see my drawing right here of my building, and because I have my units set up properly, I can put it on one of my lots. Now, AutoCAD knows that whenever I draw something 1 unit long here, as an example, I'm just going to draw a line, type in 1, and it is 1 unit long. Now we see here that this item in comparison, this is 1 foot long. That looks about right. This wall is about 1/2 foot. So that line should be about twice as long as that wall is wide. If I select it here, I press Control-C to copy that object. And I go back into my architectural drawing. Remember, I'm bringing in an object that's drawn into 1 unit, and it should be twice as long as this wall is wide. Control-V. It's not. We see it's much smaller. Very much smaller. Because in this drawing file, AutoCAD sees 1 unit as being 1 inch. So that kind of gives you an idea. But when I'm using the reference files, then AutoCAD says, hey, look, this drawing, my main drawing that I'm in, the civil example drawing, is drawn in at feet for units. And the file I referenced is drawn in as inches. Oh, that's a scale factor of 12. I need to scale this for them so everything is drawn correctly in real world lengths in units. And so it knows that. Now that's great. So that's one important reason to make sure that you have your units set up. Now, if I have these set up incorrectly, say that I set them to inches, click OK, and I try to reference this in, it's going to be 12 times too big. Now, this also works between feet, imperial units, and metric units, or vice versa. So it's great. So keep this in mind with this little demonstration here that your unit of measure in AutoCAD is relative, but it does matter, especially when you're working with other drawings defined with different units. How does AutoCAD know where your objects are? Well, it uses a Cartesian coordinate system known as the User Coordinate Systems, or the UCS. When you turn AutoCAD on and open up a drawing, you might have noticed that there are 2 arrows that appear at the bottom left-hand corner of your screen. That's this guy right here. Now, this is the UCS icon. It's there to help you keep track of your coordinate system. Now, a lot of times, if you're only using 2D drafting techniques, you're not going to notice this so much. Now, if you've ever plotted points, though, on an XY graph or chart in math class, then you're probably very familiar with a coordinate system. AutoCAD's UCS is a fairly typical system. The numbers in the X coordinate represent numbers across the horizontal axis. That's, from left to right, represented by this bottom line there and the letter X. Now, the Y coordinates are for the vertical axes, represented by this green line here and the letter Y. Now there's also a third axis because AutoCAD is a 3D modeling system, and that's the Z axis. And that axis comes straight up at you out of your screen. That little box that's right there is the Z axis. Now these 3 axes together create a 3D grid work for us to draw in. Let me kind of rotate my view here, and you can really see your X, Y, and Z axes right there. This is what they kind of look like. Now I can get back to that pretty easy. Okay, now we're back in a 2D environment. Now as you rotate your grid, as I just did, and like I'm going to show you again, you'll see that the UCS icon rotates accordingly. I'm doing this by holding down the Shift key and the scroll wheel all at the same time. And then I'm moving the mouse around left to right, up and down, and it kind of rotates about that vertice point. Now to get back, just type in the word plan, press return, and then W. That will return you to the world coordinate system. Now, every AutoCAD file comes with a default coordinate system called the world coordinate system. Each coordinate in AutoCAD along an axis is 1 unit long, whatever your units may be. As you move your mouse around, you can display the current coordinates for that point. Now, by default, AutoCAD doesn't come with this option turned on. So you'll need to go to your status bar customization button here in the bottom right-hand corner of your screen, left-click it, and at the very top is a coordinates option. Select it to turn it on, and you'll see here that the coordinates are now on your screen. As I move my mouse around, my coordinates change. And the main vertice point of your UCS is at coordinates 0, 0, 0. So the number on the left, as with all standard Cartesian coordinate systems, is the value of that point on the x-axis, the horizontal axis. The number in the center is the value along the y-axis, or the vertical axis. And the third value is the z. So you can see I'm working in a 2D environment. I'm not moving in all 3 dimensions, so my z value stays at 0. So let's draw some lines here and find their coordinates. So just start the line command, type in the letter L, then enter, pick a point anywhere, and then pick a point for your second point. Start the line command again, pick a point, turn on your ortho projection. It's down here, or you can click the F8 button, and to the right, type in the letter 5 and then enter. Press return again. So now we have a couple of lines here, one that's at an angle, one that's a horizontal line 5 units long. So once you've drawn these lines, select any of them. So let's just select this line here. Now place your line on that blue box. It's called a grip. Kind of just snaps right to it. You see the coordinates down there. Those are the coordinates for that endpoint. Come down here. Boom, it snaps right to it. There are the coordinates on my right as well. Now you can see here that the y value stays the same and that the x value has a difference of 5 because it's a 5 unit long line. Now let's turn our snap and grid displays on. Our grid display is already on, but if it isn't, press the F7 key. That will toggle it off and on. So press the F7 so you can see the grid, and then press F9 to toggle the snap off and on. Or remember that you can come down to your status bar. If I click here, this button is for my snaps on or off. This is for the grid to turn it off and on. As you move your mouse around, the coordinates will change, and as you move to the right or up the screen, they increase. As you move left or down the screen, they decrease in value. Every coordinate system has an origin, and it's typically found at coordinates of 0, 0. AutoCAD works the same way. So as you can see, the closer I get to this center point here or vertex, the closer my values get to 0, 0. Now you can draw objects to a static coordinate point. For example, let's draw a line that starts at the origin and goes to coordinates 3, 4. So they're going to come out to somewhere around here-ish. We'll start the line command, type in 0, 0, press return. We're going to press F8 so that I don't have my ortho on anymore. And I want them to be at 3, 4. So now I type in 3, 4, press enter. I'm going to press enter again. So if I select this line and I look at these coordinate points, they're at 0, 0, 0. If I come up here, they're at coordinates 3, 4, 0, just as I wanted them to. Now, a lot of times you will ignore the z value. If you don't type it in, it will default to a value of 0. So keep that in mind. Now, if you have dynamic input turned on and you want to type in those coordinates, start the line command, type in 0, 0, and that draws the line to wherever you want it to go to. Or you can type in 4, and if you hit tab, you can go into an exact angle, which is not what I want to do. I want to go to exact coordinates. But you can go to exact coordinates, or you can go to a length and an angle. We'll talk about drawing it at an angle a little bit later on. But just keep that in mind. When you work with the dynamic input or work with the command line, You input the coordinates in essentially the same way. By default, AutoCAD sets up the UCS in a world coordinate system. That means that the origin is at coordinates 0, 0, 0, and that angles facing east or to the right side of your screen start at 0 degrees. Now, there are times when you need to work with a different coordinate system. An example of that might be of a surveyor needing to work with a coordinate system that is offset, possibly rotated, from a specific point of commencement or some other land-based marker. Now, this will allow the surveyor to work in a coordinate system very easily that is relative to the property boundary, but yet still relative to its referenced real-world coordinates. Now, another reason to rotate your UCS is to draw in an isometric or rotated plane. Now, to change all these settings, we use the UCS command to create or change a UCS. Just type in UCS on the command line. That's the easiest way to get to it. Or you can go to the Visual tab on the ribbon. Now, by default, they've turned that off. So that's okay. If you just come up to this top bar right above the panels here in the ribbon where a tab would be, but it's kind of blank, right-click on it, and you can make some slight customizations to some of the things you have here. If you go to the Show Tabs option, you can see here that the Visualize button has been turned off. Just select it, and that will load up a visual tab for your ribbon. Now, there are a lot of different 3D modeling options in here, but it's one of the best ways to get to your coordinate system controls. So you can also get to it here, and you can get to a lot of different things. You can show the UCS icon, you can get to the UCS icon properties, or you can just get to the UCS command right here. If you select it, it starts it up, and you can put your UCS wherever you want it to be. You can put it into a new location or wherever you would like. Now, you'll note here, once you start the UCS command, that you have a lot of different options available to you. You can create a new UCS based on any of the options listed there. You can also get to a lot of these options simply by right-clicking on top of the UCS icon. You can go back to your world coordinate system just by selecting the world option. Or you can create a new UCS. You can select that by origin. So you just pick a new point, and there's a UCS. And you can see the little box is off in the corner. That tells you that this is a customized user coordinate system. It's not the world coordinate system. So if I select the UCS, I also get some grip options, which we'll talk about later on. But if I right-click on it, click World, that puts me back to my regular world coordinate system. So if I have a line, or any other object, but I'm just going to pick a line, and I right-click on my UCS icon, and I select the Object option. I pick an object, and as you can see, it gives me a little preview. That becomes my new user coordinate system. So it moves my UCS to a new origin, and it rotates it to match the angle of that object I selected. So now if I draw a line, and I turn on my ortho by pressing F8, it locks me into these orthogonal lines, which are normally perfectly horizontal or vertical, but in this case, it's matching the horizontal and vertical of my new user coordinate system. So this is a great tool, as you can see, quite easily to draw things at specific angles. Now, when you work in 3D, the UCS is key. Now, there's a function called the Dynamic UCS feature that will automatically change your UCS to match the face of an object, allowing you to draw on that same plane as the object is selected. That's probably one of the most commonly used cases of changing your user coordinate system is when you're working in 3D. Now, that's getting a little bit heavy, of course, for this course, but it's hard enough to keep track of just 2 axes, much less, 3 or 4 or 5 different coordinate systems that you might want to use. So we're going to try to keep it more simple for you in this introduction. So you can create your new UCS from scratch by picking a couple of different points. You can even select the icon and just rotate it or move it. Of course, my ortho is on, so I'm going to turn that off. And as you can see here, it's quite simple to just rotate the UCS that way. You can grip edit it just to move it to a new place or to make slight rotations, whatever you need to do. Now, after you create a new UCS, you might want to save it. In fact, you probably are going to really need to, in case you want to use it or go back to it later on. So create the UCS like we've described using any of these methods as you want. Now, if you come up to the Visualize tab again, and you see here we have unnamed, world, top, bottom, etc., I can click on this little button right here. It says Flyout, and this will get me to my UCS Manager. So I can get to it that way, which is a real easy way to manage it, or I can come up here to my UCS named UCS option. I can select that, gets me back to the same place. And if I go to my UCS icon, right click on it and click on the named UCS option. So when I come here, it tells me I have two different options. Essentially, I can go back to world coordinate system. If I select it and hit the set current option, then that's where it will take me. It'll set this selected UCS as my current UCS. Now I can select the previous one, and that will take me back to whatever UCS I was using right before the current one. Now this is the current one and it's unnamed. If I select inside this box, once I pick it again, I can give it a name. I'm just going to call it Custom 1, press Return. Set current, and it's current. I click OK, and I have it saved in here now whenever I want to use it. So let's say I go back to my world coordinate system. And if you note here, I'll open up my UCS Manager, go to my named UCS. I have the Custom 1 as a possibility. I select it to highlight it and then hit Set Current. Click OK, and it brings me right back to where I was. So if you go to the trouble of creating a custom user coordinate system, then you really need to save that in case you need to go back and continue working where you were before. So that's one trick that you can use to help you work in a different coordinate system and to manage that as well. Using a rotated UCS is great for isometric drawings, as you could probably see. But AutoCAD does have a specific mode for that called isometric mode. This allows you to toggle your rotation very quickly and is actually quicker and easier to use than UCS. Let's open up our drafting settings dialog box by right-clicking the snap icon in the status bar. So you come down here, right-click on it, go to snap settings. So go to the snap type option here and click on the isometric snap. That's what you're going to want to do. You want to turn that on. That will turn on isometric mode and click OK. So now you see here, you have a sort of skewed and diamond shaped set of crosshairs. So let's start drawing. If I draw here and I turn on F8, this will lock me into isometric mode so that I can now draw 3D isometric set of line works. So I can kind of draw an isometric view of a cube. So I can come down here and I can press F5 to toggle through my different isometric planes. And you can see as I toggle through them, my axes change. And so by very quickly pressing the F5 button, I can very easily draw whatever it is I need to draw. It looks like I've drawn a 3D box, though I've never left my 2 dimensions. So whereas drawing with UCS can make an isometric easy, it can, but it's in one plane only. So you have to keep changing your UCS to get that special look that you need. You can also use the isometric settings, and you can go to that just by right-clicking on the snap settings, click the snap settings button, and make sure the snap type is turned to isometric to do that special view. And you press the F5 button to toggle through, or you can click here on the status bar to toggle through the different isometrics, tops, and other views that you want. And when you're finished, make sure you turn this back. And there you go. So you can see how a UCS that you've customized can really help you out in making specialized drawings. There are 2 drawing aids in AutoCAD called Grid and Snap. They often work together, but you can also use them separate from each other. Let's start with a blank file. If you don't have one already, just go to the New tab and click on the AutoCAD.dwt template file. Snap is a toggle setting that is either on or off. If you press the F9 key, that will turn it off or on. You can also come down to the status bar, and if you come down to this icon right here, it looks like a little grid work of dots. That's the snap mode. If it's gray, it's turned off. If you left click on it, that will turn it on. It will be highlighted as blue, and your command line will tell you it'll say Command Snap On. Now what the snap feature does is that it restricts your mouse movements to specific increments on an invisible grid. Now you can set these increments to whatever value you need to. If you need to draw objects at incremental units or factors thereof, then snapping is the way to go. It helps you to draw in these increments every time without any doubt and without tedious data entry. The snap technique is not very useful when you are zoomed out too far, because the farther you are zoomed, the more difficult it will be to see where you're snapping to. As of right now, I am actually snapping to different increments. If you look at my coordinates screen on the very bottom, right here in this area, you can see that it's snapping to very specific coordinates. And when you snap, you're snapping to a defined grid. Now, that grid sometimes can be made to line up with the grid pattern that you see on my screen right now. Pressing the F7 key will toggle the grid off or on. Now, even if it's off, it's just visibly turned off. You're still snapping to those specific coordinates. And you can come to the status bar down here and left click on this icon, and that will turn the grid off or on as well. Now, to change the snap settings and the grid settings, you need to get to the drafting settings dialog box. You can do that by right-clicking on either one of these two snap buttons, the snap or the grid, and click on the snap settings. This will take you to the snap and grid options. Now you can turn off snap and you can turn off the grid by clicking on these boxes here, and you click OK, and then everything will take place. If you go to the snap and grid tab here and you go to the snap option, you can set the number of units each snap location will be set apart. Right now they are set at 0.5 units on the X or on the Y. Now you can make them so that they're universal, meaning that they are identical, they're the same, the X and Y axes. Or if you uncheck that box, you can set one of them to 10 and you can set the other one to 1, or whatever value that you want to set them to. Typically though, you're going to want these to be the same, whatever they are. So now if we click OK, and if you see the coordinates move to tenths. Now if I zoom in, you can't really so much see where I'm zooming to now for every 10 units, because I'm zoomed in too far. And when I zoom out, you can see it a lot better. And you can really see the snapping when you start like the line command, for example. So if I start to left click, and you can see as I move my cursor, everything is snapping in increments of 10. So if I go left or right, it's going at 10, 20, 30, etc. If I come straight up, it's going at 10. I just zoom out a little more, 30, etc. And as I move from corner to corner, of course, my exact distance is going to be relative to the number of units that I go up. So I can snap very easily to specific coordinates. That's the point of using the snap feature. Now it makes it easier to follow if your grid is set up at the exact same increments. So again, if I click on this arrow or right click on either of these icons and click on the snap settings button, I can get to it. In my grid spacing here, I can set up to be 10 units as well. And every major line will be set up at every 5 units. That's the way it looks. The major lines are these darker or thicker lines. So now when I draw my line command, if I snap here, you can see I'm snapping along the grid lines. So that's key. So if you want to graph something like you would with regular graph paper and a pen or a pencil, you can do that. Set your snap settings to a specific grid size and set your grid to that exact same size. Now, many users find the snap and grid features to be annoying because a lot of times if you zoom out really far, the grid changes and it's relative to your screen size. So as you can see here, I'm snapping to tenths. You can tell by my units. As I move, it goes to 20, 30, 40, 50, etc. So I zoomed out enough to where the grids try to keep a sort of semi-relative size to your screen. So they're not true grid sizes. So keep that in mind. They're really just a visual guide. And for that reason, a lot of users find this to be rather annoying. However, many users find them to be extremely useful. And I would agree with both perspectives. The ability to control where your crosshairs go without having to think about it can be very handy especially when you're first using AutoCAD. It's also nice if you're laying out circuitry, pipe networks, or you're just trying to sketch something very quickly. Having a grid to help you visualize the length and location of your drawing objects is also very useful. I typically work with the grid on, but the snap turned off. Learning how big something is on the screen can take some time, so having a visual aid is very useful. Now, eventually, and it may take some time, and that's okay, you will be able to understand how big something is on your screen. But again, it could take some time. Don't worry if it takes you a long time, though. That's okay. In fact, some people never even get the hang of it, and that too is okay. So I suggest that you often will work with the grids on at least. It will just kind of help you to give you a visual idea of what direction you're going, how you're working. If something is parallel, perpendicular, vertical, horizontal, it can be a great visual aid. If you have more than one object in your drawing, and trust me, you're going to find that you need to navigate within your drawing. Now, one way to get back and forth is to use the pan command. So let's open up a file that has something in it. So let's just take a look at the mechanical example imperial drawing file that comes with this chapter. It's just a simple drawing. It has a front view, top, and side. Now, panning is not that difficult, not anymore. For many releases, we've had real-time panning. That means you can see where you're panning. The screen moves with your pan, essentially. There are many ways to get to the pan command. If you're not in any commands, just sitting around, and panning sounds like a fun thing to do, you can type in the word pan, P-A-N. Press enter. You get this little hand, and it's on your screen. You left click, hold it down, and then you just move around. That's the pan command. Press enter to get out of it, or the escape key. Very simple. Now, there are other ways to start the pan command. You can just type in the letter P on the command line, press enter. There you go, you're back to the pan command. You can find it in the ribbon. Of course, you got to hunt for that. If you go to the View tab, it should be in the Navigate panel. Now, by default, the Navigate panel is not shown. So if you right-click on any one of these panels, but not on one of the commands, go to the Show Panels button, and you'll get a couple more options. Click on the Navigate, and that shows up right here. Now, this is turned off by default, but it is available. If I just click on the pan button right there to start the command, you can see I have access to the pan command. Nowadays, most of us don't use these buttons on the ribbon. That's why they're kind of hidden, but still there in case you want to. But nowadays, most of us just use the scroll wheel on our mouse to pan. So if you take your scroll wheel, click it and hold it, that'll bring up the pan command, and you can just move around. The nice thing about this is that you can use it while you're in the middle of any command. That's because the pan command can be a transparent command. That means you can use it while you're working within another command. Otherwise, you're restricted to using one command at a time. Now, I can't draw a line and a circle at the same time, but I can pan while I'm drawing a line or while I'm drawing a circle. So if you pick the pan command from anywhere, it will automatically be a transparent command. But if you want to type it in on the command line, you must first type an apostrophe, then the word pan. So if I start the line command, as an example, start drawing. If I use my mouse, I can just pan. It's that simple. That's why we typically don't go to these commands anymore. If I click the pan command inside the ribbon, and I can pan around, but I kind of lose where my line work is. So to get out of there, just press enter, and I'm still in my line command. Now if I want to type it in, I have to first type in an apostrophe, and then type in the command, pan. Now it's transparent, and I can move around. If I just try to type in the word pan, AutoCAD doesn't know what to do. So as you can see, the absolute easiest way to use the pan command is with the scroll wheel on your mouse. Now, one little caveat that you might find, if you're using a Logitech mouse, a lot of times it doesn't work. Sometimes it'll work for a while and then just stop working. I've used a lot of Logitech mice in my time, and I love them. One way to get around that, though, is to download some Logitech driver software. Make sure your drivers are up to date, and make sure that you have the software that runs in the background that manages the Logitech mice settings. Now, other mice might have this problem too. I'm not really well aware of them, but typically it's not going to be an issue. But I have found that to be true, and I thought I'd throw that in for you, just in case. The zoom command is actually a simple tool to use, but it is difficult to a degree. That's true because there are a lot of choices to choose from, but yet most of us only use 2. Let's open up a file that has something in it so we can actually zoom in and out. I'm just going to open up one of my recent files here. I'm going to open up the mechanical example file. This comes with this chapter, so you should be able to browse to it and open it up if you haven't opened it up recently. Now, the zoom command is the act of moving closer or farther away from your drawing data in order to get a different view. It doesn't change your drawing in any way, just the way that you're visualizing it. Now, there are many different ways to zoom. If you go to the ribbon and you go to the View tab, you should have a Navigate panel on there. If not, right-click on the panels. Don't right-click on any of the commands, just on the panels somewhere. Go to Show Panels and go to the Navigate button. It should have a check mark. If it doesn't, click it and it will open up the Navigate panel. Now, you have a lot of zoom commands available to you here. That's right here. By default, mine is saying Extents. But if I click on this little flyout arrow, you can see here that I have several different zoom command options. There's Zoom Extents. If you click that, it will zoom out or in depending on where it needs to go. It will zoom in such a way so that it will fill the extents of your drawing area with the extents of your line work. So all of your line work will be exposed and will fill up your screen. That's a really great tool, and I like Zoom Extents a lot, and I use it often. Another option is the Zoom Window. If you click on the Zoom Window button, this will allow you to draw a window on your screen, and everything inside that window will be zoomed in and will fill your display. So I'm going to click here with a left click, and then I'm going to draw my window. I can move it to the left or right, up or down. As you can see here, this is the window that's being created. So I'm going to look at this part, left click again, and it zooms me into that spot. That's a zoom window. So Zoom Extents and Zoom Window are probably the 2 most often used zoom options for people. For me, that's about all I ever use, to be quite honest. I can navigate through my drawing almost everywhere with the Pan command, Zoom Extents, and the Zoom Window. Now you have the Zoom Previous. That will just take you back to the last state of zoomage, as I'd like to say, but your last zoom state. It takes you back there. If I click on it again, it takes me back one step even further. And I don't have any more zoom previews saved. So that's what that does. Now, real-time zoom, this will zoom as you drag your mouse, left click, and then drag your mouse up or down diagonally, back and forth, and it zooms in real time. So that's kind of handy if you want to zoom in on something slowly and still see everything as it's zooming in. Now it's going to focus on the center of your screen. You don't really focus where you click at. As you can see, I can click anywhere, and as I move up or move down, it zooms in or out accordingly. That's real-time zoom. As I said earlier, a reason to use that is so that you can zoom in slowly, accurately, and it's very easy to see what you're zooming to. One reason not to do it is that it's very slow. Now, Zoom All. Zoom All is very similar to the Zoom Extents, only that it will zoom to all of the places you have ever worked at in this file. So if I've done some work over here, let's say I've drawn a rectangle. If I do a Zoom Extents, of course, it's going to zoom in and show all of my line work and just fill the screen the best way it can. If I go to Zoom All, kind of does the same thing. You can see that there. If I remove this, I click on Zoom All, it remembers an area that I've gone to before. Now you see that rectangle kind of moved away, but it will zoom and display all the objects, as the tooltip says, that are visible, along with your visual aids. You can change the magnification and settings for the Zoom All so that it will fit something very specific if you'd like to. However, the majority of the time, you're not going to spend the time to do this. The dynamic zoom is really cool. This used to exist before we had the Zoom Extents and Zoom All. If I click on dynamic zoom, it does a Zoom All essentially, and then it gives you this window. Now, if I left click and slide left or right, it shrinks or increases in size the size of that window. And then I can pan it around and move it by left clicking, holding it down, putting it into position, letting it go, and then I can zoom it in or out again. And when you're done, just press enter and it zooms in to that spot. So let's say I'm zoomed in really closely to this circle, but I need to zoom into something in the side view. Well, that's where dynamic zoom comes in handy. It kind of zooms all the way out, and then I can take my window, move it over there, left click to kind of pick where it is, and press enter, and it zooms in there. So it's one command that does two different zooms. It's a zoom out, and then it's a zoom in. That can be very useful and very helpful so that you can get to wherever you need to. Scale will zoom by a specific scale factor. I typed in 2 there, and I'm going to type in 6. If I type in 9, it keeps zooming in. If I scale to 0.5, it zooms out. So if your zoom scale factor is greater than 1, it's going to zoom in. If it's less than 1, but greater than 0, it will zoom out. If I click center and then pick another line, it zooms into those two lines, kind of like the zoom extents, but it just extends into those two lines and then puts the middle of that right in there. Let me try that again, except this time I actually click on something there. It goes like that. See, it kind of zooms it in and centers it. So in a way, it's a little bit like the zoom window, but with a diagonal line. Now the zoom object is quite simple. You select the object, press enter, and it zooms into that object, filling the screen with that object. So if you want to see something very specific, that's a really great zoom tool to use. And then you have zoom in and zoom out. This just zooms in just a little bit, and zoom out, zoomed out just a little bit. So you can see here the zoom command is very complicated. You have a lot of options available to you. Now you can get to these on the ribbon, or you can get to them on the command line. Just type in the word zoom, press enter, and you have all of your options right here on the command line. Just pick the one that you want and perform the zoom command. Now, another way to zoom in is with your scroll wheel. You just zoom in or zoom out just by scrolling your scroll wheel. And then if you pan around with that same wheel, you can get to just about anywhere in your drawing just by doing that. 95% of the time or so, I'm going to say that's exactly what I do. The other thing I will do is do a zoom window. If I just type in Z for zoom, W for window, and that'll give me exactly where I want to go. Now another quick way to perform a zoom is a zoom extents, and that's also with the scroll wheel. Double click on your scroll wheel, and that performs a zoom extents. So between the zoom extents and then the scroll wheel zooming in and out, and then the scroll wheel being able to pan, that's about all I ever do. I hardly ever go to the zoom command. If anything, I just type in Z as my keyboard shortcut for the zoom, press enter, then W for window, and I'll do that. So as you can see, the zoom command gives you a lot of options. It's very complicated that way, but there are a couple of very simple tools that you can use for almost all of your zooming needs. To finish up this chapter, let's review what we've talked about with a little project. We'll just go over a few simple steps that will allow us to practice some of the concepts in this chapter and maybe give you a little hint of some things to come. Most of the chapters are going to have a similar project at the end, and many of them will build upon the previous one, culminating in our end of the video big main project that we're going to do. So let's get started. What we're going to do is draw a few shapes, some rectangles and triangles, but we're going to use different methods to do this with. So first we need a file to work with. If you're not in the new tab already, you can just click on the plus sign there in the tabs, and that will bring up the new tab for you. Go to the Get Started area and click on Templates. We're going to use the AutoCAD.dwt template file. Now before we can get started, it's a good idea to save our file ahead of time. That way we know we're working in the right file, and whenever we save our progress, it will be saved. So go up to the Application menu and click on the Save button. This will allow us to save our file. Browse to the location where we're going to save your files at. I am going to call this file Chapter 4 Project. I have a file that I've already started where I tested out all of my settings and everything that I'm going to use for this to make sure I was doing it correctly. I'm just going to override that. You'll have this file with your DVD, and it'll be available for you to check on, to kind of get a look at it and to compare it to what you're doing. I'll do that with all of the projects. I'll give you an example file of what we've done. And that way you can check your work and make sure that you're on the right page, so to speak. So here we are, Chapter 4 project. We have the file started. It is saved. So we want to make sure our units are set up correctly. Type in the word units on the command line and press enter. Now I want to use architectural drawing length type of units, and we're going to go in inches. So make sure this is set to inches on your insertion scale option settings. 1/16 precision is enough. The angles for here are perfectly fine for what we're going to do, and then click OK. Now, as you work on your file, I've mentioned it before, you need to save early and save often. So we've done the save early. Now we've made some changes. Now let's save our file. Press the Control key and the S button on your keyboard. This will execute a quick save. So it just saves the state of your file wherever it is at that moment, and it saves it and it keeps it. So we have our units set up properly in our saved file. So if something happens to our computer, to AutoCAD or to anything, it just crashes, which will happen, I haven't lost any of my work. So let's begin. Make sure your grid is turned on because I want to demonstrate how the grid in snap mode works to you. So if it's not, you can press the F7 key, or you can come down to the status bar and click on the little icon here. This is the grid icon. If it's blue, it's on. If it's gray, it's turned off. Now let's draw a rectangle. Go to the Home tab in the ribbon on the Draw panel, and here is the rectangle command. Click it, and you can just draw a rectangle anywhere of any size and shape. I just want to give you an idea of what it looks like relative to the grid, because now we're going to change the grid. We're also going to turn on snap mode. So press the F9 key or come down to the status bar and click on the snap to drawing grid option, snap mode. Now we need to go to these settings. Click on the little flyout arrow, click on snap settings, or you can type on the keyboard OS. That will also bring up your drafting settings window dialog, which is what we have here. But make sure you are on the snap and grid tab. Snap should be on, grid should be on. Now we want to go to our snap spacings for our X and Y. We're going to use the same settings for both of these, and it's going to be 10. Click 10. If you press enter, this is what happens. It closes that window. That's okay. Just type in OS and go to the snap and grid tab. Now you can see it did set our X and Y spacing for us the way we wanted to. So if you're just changing this one item, type it in, press enter, and it saves a couple of steps. It's real quick and fast. But we want to do some more settings here. We're going to change the grid settings now so that our grid lines actually matched where we're snapping to. So we're going to change this also to 10 units. Now we have 10 and 10 throughout. Make sure your other settings match. Click OK. Now you'll see here now our grid has visually changed. So our grid reflects that every line is 10 units away or some factor of that. As we zoom in and out, you'll see that it kind of gets a little bigger or smaller, but they're relative to each other. Now, one thing you may have noticed as what's going on right now, I can't zoom out any farther. Sometimes that'll happen. And sometimes when you pan, it gets locked in and you can't pan anymore. If that happens, it's just a glitch in AutoCAD. Type in REA for regen all and press enter. Now I can zoom in and out. It's going to happen often to you as you zoom out and zoom in, especially when you zoom in or zoom out really, really far. So that'll happen. Just type in REA and it'll loosen things up for you. Now I want to get rid of this rectangle. Select it and then press the delete key on your keyboard. That will do the same thing as erasing it. Or select it and click on the erase command from the ribbon. Or type in erase, E-R-A-S-E, press enter, select your object, and then press enter again. Now remember, a lot of commands like erase, move, or copy, you can either select the objects first and then start the command, or you can start the command and then select the objects. Just a matter of preference for you. Okay, now we're going to draw a couple of shapes. Snap mode is on, grid is on. I'm going to demonstrate to you two different ways of drawing triangles. This is our origin right here. We want to be close to it because I'm going to draw a triangle in this area right around here with absolute coordinates. But before we do that, I want to demonstrate to you snap mode. I'm going to show you how easy it is to draw shapes and things very quickly. Start your line command, and we're going to draw a triangle. Now that it has started, the line command, You can see I'm trying to pick my first coordinate point. My snap mode is keeping me in line with my grid. Now that's very handy because it lets me know I'm drawing at units of 10. Every line is 10 inches. So that's great. So I just left click and I drew my line starting right there. I'm drawing a triangle, so I'm coming straight down. I'm going to draw a right triangle. That's a 45 triangle. I'm going to click down here as well. You can see I have my 2 lines. And now I'm just going to close my triangle, left clicking up there, press enter, and there we go. Using my scroll wheel to zoom out and to pan. So that was a quick and easy triangle. If I start my line command again, I can start anywhere I want on my grid and draw several different shapes. So the snap mode with the grid, especially when they're both lined up together, makes it very easy to draw shapes very quickly. So you can do a lot of quick sketching this way. But if you want to get precise, you can. So I'm going to start the line command again. I'm going to draw another triangle, but I'm going to start it at coordinate 1, 6. To do that, you just type in the coordinates 1, 6, after, of course, you've started the line command. Press enter. Now my snap mode is still on, so it's keeping me at these 10-inch grid marks. So I want to draw a line, though, that's perfectly horizontal. I can't with the snap mode this way, but you can override it with your coordinates. Now I want to draw it at an absolute value coordinate of 11, 6. So in order to do that, I need the hashtag or the pound sign. Type that in first, then type in your coordinates, 11, 6. Press enter. And there it is. Now I want to draw a line that's straight up at 3 units. I don't want to do the math to try to figure out what coordinate that is. That's okay. I can use what's called a polar coordinate system. I use the @ symbol this time. So I start with the @ symbol, type in my length, which is 3 units long, press the tab key, and then I want to draw it at 90 degrees. Press enter, and there's my other leg for my triangle. Now I want to close this. Now my other triangles over here on the right, I just went to my snap point and I was able to just click there and it drew exactly what I wanted. But because this coordinate isn't on one of those grid points on my line in snap mode, I can't just do that. Well, there is an option in the line and the polyline command called close. If I just type in CL for close, it'll close my shape and end the command. And there we go. So I drew essentially 2 different triangles and 2 different methods that were very easy to do. Some of them were more precise and some of them were fairly precise with the snap mode, but yet it was very quick and easy to do. As you can see, this method took a little bit more time and effort. Now, when do you use them? Well, it depends on the information that you have at hand and what you're trying to do at the time. So we'll take a look at a lot of these different types of methods throughout the rest of this training video.